What's up, guys? Thanks for clicking on another one of my videos. In this one, we will be doing some more factoring. More specifically, we will be doing difference of two squares, difference and sum of two cubes, and then also factoring by grouping, which unbeknownst to you, you might have already learned if you watched my previous video on factoring trinomials. So yeah, let's jump right into it. Just like in any factoring problem, you must take out your GCF. So I will take out a 2 here, and when you divide everything by 2, you will have x squared minus 9. And you'll notice we're kind of used to having 3 terms in there if you watched the previous video, right? We're used to having something like x squared plus 3x minus 4, or something along those lines, where you have a term with just an x. And we don't have that here. And that kind of makes our life easier. All you do here is make 2 sets of parentheses, just like before. The x squared, just like before, becomes an x and an x. And all you do is you take this number and you square root it. So you're looking for a number times itself that gives you 9. So what times what gives you 9? Of course, 3. So we will put a 3 here and a 3 here. One gets a plus, one gets a minus. Of course, we said that if that's a minus on that last term, then your signs are different. Not that that matters here. Just remember when we have the difference of two squares, so a minus sign in between, that makes it the difference. And then 2 squares basically just means 2 things we can square root. The square root of x squared gives us x. The square root of 9 gives us 3. And that's all we do. We just have x and 3, x and 3. One gets a plus, one gets a minus. And that's the difference of 2 squares. Honestly, it's much easier than factoring in the previous video. So let's try that again in this problem. Notice how we have a GCF once again. We must take out that x. We don't have a GCF between the 4 and the 25, so not much to do there. But we will have 4x squared minus 25. And again, we are going to have the difference of 2 squares. There is a coefficient on the x, though, or on the x squared, rather. But we have the difference of 2 squares because we can square root the first guy and get 2x, right? We square root the 4 and get 2, square root the x squared and get x, and then we can square root the 25. We will get 5. One gets a plus, one gets a minus, always with the difference of 2 squares. DOTS, difference of 2 squares. Dots. So we just dotsed this equation. All right. So x cubed minus 27. Notice how there's no GCF, but now we have an x cubed. So we should be on the lookout for the difference of 2 cubes now, or the sum of 2 cubes. Now I've talked about the difference of 2 squares, but there's no sum of 2 squares. So if I go back, if this problem had a plus in between, it's not factorable other than taking out the x, which is your GCF. So there's the difference in sum of 2 cubes, but there's no sum of 2 squares. Not a thing. So back to this problem, x cubed minus 27. What you do here is you make 2 sets of parentheses. One's going to have 2 terms. One's going to have 3 terms. So I'll make the second one a little bigger. And what you're going to do is you are going to cube root everything. So you're asking yourself, what times itself gives us x cubed? And that, of course, is just x. What times itself gives us 27? Well, 3 times itself. 3 times 3 times 3 gives us 27. And that is what goes right there. Here's what you do next. You're going to square this guy, put it right there. Square this guy, put it right there. And then multiply these two guys and put it right in the middle of those two. There's a little mnemonic, SOAP, that you can remember to figure out what the signs are here. So the S stands for same, meaning the first sign is going to be the same as what we started with. So same sign would be negative. The next one, O, stands for opposite. So the next sign is going to be opposite of what we started with, plus. And the last one, AP, always positive. Same, opposite, always positive. And this is our final factored answer. X minus 3, x squared plus 3x plus 9. So that is called the difference of two cubes. And yeah. Now we have the sum of two cubes. Once again, we're going to need our two sets of parentheses. The second one is going to have three terms, so I made it a little bigger. And yeah, we can see that everything here we can cube root. What times itself gives us 8. So 3 2's will give us 8. And x times x times x will give us x cubed. So the cubed root of this guy, we just put right here. And the cube root of this guy, well, 5 times 5 times 5 gives us the 125. Put right there. Same, opposite, always positive. So the first sign is going to be positive because it's the same as what we started with. Next step, what goes right here? Just this guy squared. Make sure you don't forget to square the 2 as well. What goes here? Just the 5 squared. And then what goes in the middle, we multiply these guys. So notice how we're always relying on this to figure out what goes here. I think it's a very good way to look at it. So we will have a 10x in the middle because we multiply the 2x and the 5. So the second sign is opposite, and the last sign is always positive. And there you have it. 2x plus 5, 4x squared minus 10x plus 25. All right. Now we're going to look at some grouping. And this will be very, very, very similar to factoring trinomials when we had a coefficient on the x squared. If that means anything to you, great. If not, just kind of watch. So notice how we do not have a GCF here. We can't take out a 2 from this guy, although we could have from this, this, and this. But you need to be able to take out something from everything if you have a GCF. And this guy doesn't have an x to take out. So we're kind of out of luck here. So what you're going to do next is you're going to try to factor out the GCF of just the first two terms and then factor out the GCF of just the last two terms. You're kind of approaching this like it's two different problems. So the GCF here, well, they both have a 3 in common and they both have two x's I can take out. So I'm taking out a 3x squared, and what I will have left inside is a 2x and then a minus 5. And you can check that by distributing the 3x squared to see if you get back to the 6x cubed minus 15x squared. Next, I'm going to take out a 2 from the 4x minus 10. And notice how I put a plus there because I took out a positive 2. That's very important because you're not trying to show that you're multiplying this by that. So you need to show that you have some sign in between. And when you take out that 2, you have a 2x minus 5 left inside. And that's great, and this should look familiar to the factoring of trinomials because we see that we have something in common. Whatever that is goes in one set of parentheses, and whatever's left over when you kind of get rid of them goes in the other. So 3x squared plus 2 would be left. And that's it. That is our fully factored form. You can check and see that that's not factorable, that's not factorable. So not much going on there other than what we have on the screen. One last grouping problem. So I will approach it the same way. Factor these two guys, factor these two guys. So when I take out a 2x squared from the first two terms, I will have a 2x minus 7. And then when I take out a 3 from these two guys, I will have, if I take out a positive 3, I will have a 2x plus 7. Actually, a negative 2x plus 7. And notice how I don't have anything in common here. These aren't the same things. What that means is I probably need to flip my sign. So instead of taking out a positive 3, I'll take out a negative 3. And then I'll have a 2x minus 7 left over, which is great because that's what I had originally in my first thing. So notice how if I distribute the negative 3, I get back to where I started. So you kind of have two options here. You could have factored out a negative 3 or a positive 3. You just need to do it depending on what this is because you want to match these two. All right, and same deal here. Two sets of parentheses. Whatever they both have, that goes in the first one. Order doesn't matter. You could have put it in the second one, but whatever. And then whatever's left over when you kind of cross them out, you'll put in the last one, 2x squared minus 3. And there's your answer. 2x minus 7, 2x squared minus 3. No big deal, right? Grouping's not that hard. But yeah, so we learned 3 things, or actually 4. Difference of 2 squares, but not sum of 2 squares. That's not a thing. So make sure there's a minus sign if they're 2 squares. Sum of 2 cubes, difference of 2 cubes, and factoring by grouping. So that's all I have for you in this video. Make sure to like and subscribe, and hit me up in the comments if you have any questions.
Brad does math.